On this video, I will be solving more problems using the mole. So I promised this to you in the previous video in which I explained the mole and the mole diagram. So here they are. So there's the mole diagram we'll be using. And in the previous video, we finished with a basic conversion between from mass to mole. So let's try something a little bit different. Let's say we have the same numbers. So mass, 15 grams of gold. But this time we don't want moles, we want the particles of gold. So particles. And well, as I said before, you cannot go directly from mass to particles. That doesn't happen. So you have to go from the mass to the mole, and from the mole to the particles. And a very, very important conversion you really have to know is that a mole of anything will always have 6.022 times 10 to the 23 molecules of or particles of that same thing. So particles, we call it the same. And that is called Avogadro's number. But that doesn't really matter for now. What you have to know is that 1 mole will always be, let's say 1 mole of gold will always be 6.022 times 10 to the 23 particles of gold. So let's convert this. So as we did before, we're gonna write the given unit, 15 grams, is then open parenthesis line. We're gonna write here the given unit again and the desired unit. As we cannot go directly to particles, we're gonna write here moles first. And then I'm gonna do the same again. We have our given unit now will be moles. We'll write moles here again. And the desired unit, this time we can write particles. So particles or atoms, they're the same. Because atoms is short, I'm gonna write that. And what we'll get will be in atoms now, which is the unit we want. This is the same as particles. So we know the molar mass of gold is 196.9 grams. 196.9 grams of gold, and that will be in 1 mole. So 1 mole, and we can use this factor now. 1 mole is 6.022. Gonna erase this just for it to fit. Times 10 to the 23 atoms. And then this was 1 mole. So the grams will cancel the grams, the mole will cancel the moles, and we will end up just with atoms. So if you solve this, you calculate it, we end up with 4.58 times 10 to the 22 atoms. So I've shown you how to go from mass to moles, now from mass to particles. The same logic applies from mass to volume. So you can do that. I'll do something different now. You saw here that there's gonna be a part A, this is A, and a part B, this is B. So I'm gonna explain to you what that means now. So what that means is that sometimes you will have a molecule, and they don't want the grams of that molecule, they don't want the mass of that molecule, but they want the mass of, let's say, one of the elements in the molecule. So you will have to go from this mass to the moles of that, to the moles of this, to the mass of this. So it will be a 4-step thing. Let's try a problem. Let's say we have 10 grams of C6H6O3. This doesn't look like a 6 at all. and they want to know what is the mass of the carbon, just the carbon, not the whole molecule. So the hydrogen and the oxygen don't matter really. So we can say that this is A and this is B. Okay? So what we have this mass of A, and we want this mass of B. We cannot go directly there, so we have to go from mass of A to moles of A, from moles of A to moles of B, and from moles of B to mass of B. And it is not as complicated as it sounds. We can all do this in one long step. So let's apply the same process we have applied all the time. So the given unit, 10 grams of that. Actually, first let's calculate the molar mass of this molecule, because we'll have to use it. So it'll be something like this. This is HO666. This is about 12, 1, 16, 72, 6, and 96. And we get about 174 grams per mole. So let's erase all of this. You know how to get the molar mass, I'm assuming. Let's just write it as here. Molar mass A is 174 grams. So now let's do what I was doing before. So we have 10 grams of A. I'm not going to write C6H6O3 because it would just make it really long. And well, we found the molar mass of A to be 174 grams per mole. But we just say grams because the moles go up. So grams. And that is in just 1 mole of that molecule. Remember, the molar mass is of 1 mole. So we went from the mass to the moles. Okay, we have moles of A. Now we have to go from moles of A to moles of B. So let's call this moles of A. Now let's write this like this. So we have only 1 mole of that particle, right? So it's 1 mole of A. But there are 6 carbons in that molecule, which means because our carbon is B, we call it B, we're going to have 6 moles of B. So because the moles are amount, you can see 6 carbons there. Here there's 6. And we have 6 moles of B. Now we went from moles of A to moles of V. Now we want to go from the moles of B to the mass of V. So in 1 mole of carbon, it's simply going to be its molar mass. So the molar mass of carbon is, because it's an element, it's just 12, as you can find in the periodic table. So the grams of A will go with the grams of A, the moles of A will go with the moles of A, the moles of B will go with the moles of B, and we'll have grams of B. Forgot to write A here. So we will have we will just have grams of B, which is what we wanted at the beginning. Now we multiply and divide by the numbers. The numbers don't go, so have that in mind. 10 times 6 times 12 over 174. So that gives us 4.13 grams of carbon. And that is what we wanted. So if you organize yourself, you apply the method that I explained to you in units and conversions, it will be very simple. You just need to follow the diagram and you will be fine. So using the same logic, you can go from volume of something to the particles of something else. You just have to follow the diagram. And that's it for mole sign conversions.